This essay question asks us to compare the sampling distributions that are created by simulation, which would be stat key, or by a mathematical model such as the normal curve. Now when we're doing that, let's make sure we know what we're talking about. The sampling distribution is not the original set of data that comes in. So we have our original set of data, and then depending on our sample size, we say could we expect for the averages or the proportions that we calculate that summarize this data under different situations. And whether we're using stat key or a mathematical model like the normal curve, we end up with that basic bell curve shape most of the time. Now, the idea with stat key, if you have a bunch of data points, so let's say we collect some data, so we say how many siblings you have, 3, 2, 0, 0, 1, 2, 3, whatever. We collect our original data, and then once we have that original data, we resample from it. So that's when you click the generate one sample, generate 1,000 samples. What it's doing is it's saying, I'm going to randomly pick, since this is a sample of 7, I would randomly pick 7 numbers. 1, 2, 3, and you can re-pick the same one twice. That's possible. 4, 5, 6, 7. So in this case, there's some that ended up getting skipped, some got picked a couple times. That can happen when it's randomly picking, and it throws them back in the pile to be picked again. And what it would do is it would take those 7 numbers it picked, including the repeats, average them, and then put that average somewhere on the graph. And it would repeat that process and it'd get a bunch more values each time. And the most common ones are going to come up near the original sample average. So if we draw our sampling distribution that results here, I'll actually draw this one just as a bunch of points. So we kind of have this pattern where the most common ones are towards the middle and some are out on the edge. The middle is still going to be the sample average. Now, when you look at the normal curve, the way that we do this is we assume the shape is going to look exactly like this. The middle is going to be exactly our sample average. This is just based on lots of simulation that's predicted that this is what always happens. Our standard deviation for this curve, we don't just generate data and see what it comes out to. We actually know the standard deviation ahead of time. So this value right here, we calculate by taking whatever the standard deviation is of the original sample, like this, and then we divide it by the square root of our sample size. So in this case, we divide it by square root of 7. And that's how we can know ahead of time what the sampling distribution is going to look like. So even though these two curves look the same, we got it over here by actually just running it through and testing something many, many times over and just seeing what happened. Here we predicted what was going to happen ahead of time. Now, the difference then, or the similarity, is that the shapes are the same. They both have X bar in the center. They effectively work the same. The difference is in how they're made. So this one is made through simulation. This one over here, if we're talking about means, we would use something like the central limit theorem. And we're just going to use means for this example. I think it's easier to explain with. Proportions have the same type of idea going on. But for the essay questions, you can just use means. So simulation versus central limit theorem. Another difference is that we have to check assumptions here. So we have to check our assumptions, and those assumptions would be that we have a large enough sample size. So depending on what our original distribution looked like, we might need a sample size of at least 30, which means in this case, we wouldn't actually even use the normal model. We would say our sample is too small. We need a larger sample before we can trust that this is going to do the right thing. The other thing we need to make sure of is that our original sample is not too large relative to the population. If we have a very small population, this normal curve starts to get misshapen a little bit. We actually can run into similar effects over here, so we're not going to focus on that one as much because it actually could end up being a similarity. But the big assumption that we always check on this side is to make sure that the central limit theorem is actually going to work, that we have a large enough sample size When we're doing simulation, we really don't have to worry about that as much.